Hello, welcome to Engineers Mindset Academy. All right, so in today's video, we are going to be talking about the design analysis of a rivet joint. As we all know, a rivet is simply a component which is used to provide fastening of engineering structures or members. As can be seen on the board, these are all rivet holes where the rivets are inserted to provide fastening between an engineering structure. It can even be a wood or between metals. Now, in designing of a rivet, there are lots of failure considerations. The first thing to be considered is the design of the strength of the rivet. So that's simply called tearing strength of the rivet. Due to the load applied or due to the force applied on the rivet, there's a tendency of the rivet to tear along the line of riveting. Okay, there's a tendency of the rivet to tear along that line. So there's a need to always design the rivet considering the enrichment of the tearing strength. So the first consideration is the tearing strength of the rivet. Okay, so the first thing is tearing strength of rivets. The tearing strength of the rivet. Now, how do you find the tearing strength of the rivet? If you take a look at the diagram, this is actually a hole, and this hole is simply called the hole of rivet. Now, the circumference of this hole is given as the circumference. Okay, let's simply use C for that. Is simply given as P minus D, where P is simply the pitch of the rivet hole. Okay, P is simply the pitch of rivet hole, and D is the diameter of the rivet hole itself. D stands for the diameter of rivet hole. So the circumference of the rivet is simply given as P minus D due to what? This cycle. Okay, so now to obtain the area, now to find the tearing strength, we all know that stress, okay, sigma T, please take note, sigma T simply stands for the tearing stress. So this is simply called the tearing stress. All right, we know that stress is simply what? Force all over area. In this case now, force becomes the tearing force, which is also called the tearing strength. Okay, this is now Ft all over area. Okay, simply A. So which means in order to design the tearing strength of the rivet, it simply becomes the tearing stress multiplied by the area of the rivet. All right, so this simply implies that tearing strength Ft is simply equal to the tearing stress times the area of the rivet. Now, how do you find the area of the rivet? Area of the rivet, when considering tearing, area is simply given as the circumference times the thickness of the rivet. Okay, the circumference times the thickness of the rivet. Now, what is the circumference? Circumference is simply given as what? P minus D. All right, so this simply is equal to P minus D multiplied by what? Thickness of the rivet. So this simply implies that the tearing strength of the rivet, Ft, is simply given as the tearing stress multiplied by P minus D times thickness. All right, so this is how you find your tearing strength. Whenever the rivet is under design considerations, or whenever you're asked to design a rivet, the first thing to consider is the tearing strength of the rivet. You have to enrich the tearing strength to avoid failure of the rivet material. Okay, so the formula to calculate that is simply pitch minus diameter times thickness multiplied by the tearing stress. Now, the relationship between the thickness and diameter of the rivet hole can be found using the Unwin's formula. Okay, using the Unwin's formula. The relationship between the diameter and the thickness of the rivet can be found using the Unwin's formula. Now, what is this formula? Diameter D is simply equal to 1.91 square root of T when both the diameter and thickness are in centimeter. Okay, when both diameter and thickness are given in centimeter, or let's say the thickness is given in centimeter, that means automatically diameter must be in centimeter. You simply make use of this equation. So if only the thickness was given to you, then this is how you find your diameter. Whereas if only diameter was given to you, you can also find the thickness. Now this is a case where the thickness is in centimeter or the diameter is also given in centimeter. Now, when either the thickness or the diameter, or when both of them are in millimeter, the unwinds formula simply becomes diameter equals 6 root t. Okay, this is now when both the thickness and diameter are in millimeter. All right, so when they are in millimeter, you simply make use of this relationship. All right, so if the thickness alone is given in millimeter, automatically you can use this relationship. That simply means diameter in that case will be in millimeter. But if the diameter is in millimeter, you can also use this relationship to find what the thickness, but also keeping it in mind that whenever you find the thickness from this relationship, if diameter is in millimeter, automatically thickness also becomes in millimeter. So that's the first consideration, the tearing strength of the rivet. Another consideration is the shearing strength of the rivet. The shearing strength of the rivet, that's the second consideration. Okay. So the second consideration is the shearing strength of the rivet. So when designing a rivet, you have to consider the shearing strength of the rivet, because rivets may shear. Now, a rivet can shear either as single or double. So we have what is called the single shear, we have what is called the double shear. Now, shearing simply means the splitting of the rivet surface at 90 degrees. For instance, let's say we have, this is a good example of a rivet. Now we have something like this, okay, and we have a split in this manner. When we have a split in this manner, this is simply called shearing. Okay, this is simply called shearing. Now observe that this shearing has been done at 90 degrees to one another. The splitting of the rivet at 90 degrees is simply called shearing. Now we can have the single shear, we can have the double shear. Double shear looks something like this. This is actually a single shear. So this is rivet in single shear. Rivet in single shear. Now, when rivets are in double shear, you have something like this. All right. So when a rivet is in double shear, you have something like this. Mind you, what propagates the shear is, of course, a shearing force. So we usually have a force here that propagates the shearing of the rivet. So this force is simply called a shearing force. Okay. This force is simply called a shearing force. All right, so this is now rivet in double shear, rivet in double shear, and this is simply rivet in single shear. But in all, this shearing is always at 90 degrees to one another, as can be seen by the diagram, or as can be seen on the diagram. They are always at 90 degrees to one another. So rivet may fail due to shearing of the rivet itself. So there's always a need to design or strengthen the area of the shear to avoid failure due to shearing. Now, how do you design the rivet considering shearing? Considering shearing, we all know that shear stress, okay, we all know that shear stress, tau, is simply equal to the shear force, okay, you can simply use Fs, all over area as well, shear force all over area. So this simply implies that the shear force is simply equal to, by cross multiplying, it becomes the shear stress, permissible shear stress, okay, multiplied by the given area. So this is simply shear stress times area. That's what gives us the shear strength. So this is simply called the shear strength. F of x here is called shear strength of the rivet. Okay, that's the force itself. Whereas tau here simply means permissible shear stress. Okay, this is called the permissible shear stress of the rivet, and A stands for the area. Now, how do you find your area? As stated earlier, rivet can be in single shear or it can be in double shear. Now, if the rivet is in single shear, it means that the rivet hole is 1. But if the rivet is in double shear, it means that the rivet hole is 2. So if the rivet hole is 1, that means your area is simply what? Just one area. But if the rivet hole is 2, considering when rivet is in double shear, then it means you're going to have what? Two different areas of that particular rivet. Hence, for that reason, our area is always considered, A is always taken as N times pi diameter squared all over 4, where N stands for number of rivets. Okay, number of rivets hole. Okay, N stands for number of rivets hole. So for a single shear, when rivet is in single shear, N is equal to 1. But when the rivet is in double shear, N is equal to 2. That simply means constructing or designing the area of the rivet. When the rivet is in single shear, you simply consider N to be equal to 1. But when the rivet is in double shear, then you take N to be equal to 2. That's simply telling you that the number of rivet hole is 2 when it's in double shear, or 1 when the rivet is in single shear. For that reason, the shear strength f of x, the shear strength is now equal to the permissible shear stress multiplied by area now is given as N times pi diameter squared all over 4, where D stands for the diameter of the rivet. So this is how you design your rivet in terms of shear strength. Okay, you enrich the shearing of the rivet using this particular formula. The third consideration is simply the design of the rivet joint against crushing or bearing pressure. All right, so the third design consideration is the bearing or crushing strength. Okay, bearing or crushing strength. All right, so you have to design the rivets considering the bearing or crushing strength. Now, failure can occur on the rivets due to intense pressure. Failure can occur on the rivets due to intense pressure. So there is always a need to design or resist that pressure by designing what? The bearing or the crushing strength. So there should be a certain amount of crushing or bearing of this given pressure acting on the rivet to avoid failure of the rivet. Now, how do you calculate the bearing or the crushing strength? It's still basically the same thing. You have your shear stress. Okay, in this case now, this becomes the bearing or the crushing stress to be equal to force, bearing force or crushing force all over the area. So which means to find the bearing or crushing force or the crushing strength, it is simply what? The permissible bearing or crushing stress multiplied by the area. So this simply implies that the bearing force or the crushing strength is simply equal to the permissible bearing or crushing stress multiplied by the area of the rivet. Now, to find the area of the rivet, in this case now, when considering bearing or crushing strength, the area of rivets A is simply given as the number of rivets hole. Okay, N is simply the number of rivet hole multiplied by diameter of rivet times the thickness of rivet. Now, the reason why we are using number of rivet hole here is simply because if the rivet is in double shear, like I said, it means that the number of rivet hole there is 2. But if the rivet is in single shear, it means the number of rivet there is 1. So for double shear, it means we are going to be having two different areas for what? The rivet hole. But for single shear, it means we are going to have one different area for the rivet hole. So we simply use N times D times T. D times T there is the area where N stands for what? Number of rivet hole involved. As such, therefore, the bearing or crushing strength, okay, the bearing or crushing strength FBC is simply given as the bearing stress or the crushing stress multiplied by the number of rivet holes multiplied by diameter multiplied by the rivet thickness. So this is the formula to calculate the bearing or the crushing stress. All right, the fourth criteria to be considered is the shearing of the rivet along the edge of the rivet plate. The shearing of the rivet along the edge of the rivet plate. All right, now let's consider that we have a rivet plate in this manner, and okay, we have a rivet hole just by the edge of the plate, something like this. Okay, now this is simply saying there is now what? This is simply saying there is a shearing along the edge of the rivet plate. and the rivet hole itself. Okay, there is a sharing along the edge of the rivet plate and the rivet hole itself. So we need to consider design considerations due to what sharing at the edge of the rivet plate. All right, so that's the fourth criteria: sharing of the rivet hole at the edge of the rivet plate. Okay, sharing of the rivet hole at the edge of the rivet plate. Let's get that down over here. So number 4 is sharing of rivets, sharing of rivet hole at the edge of plate. All right, sharing of the rivet hole at the edge of the plate. Now to calculate this, so the sharing strength is simply given as 2m times t, where m itself is a constant given as 1.5 times diameter. Okay, where m is a constant simply given as 1.5 times diameter. So if you put in that value, this simply means that the sharing strength, okay, at the edge of the rivet and the rivet hole itself is given as 2 times, in place of m is 1.5 d times t, okay, times this t, and this is simply implying that the sharing strength is simply equal to 2 times 1.5 gives us 3 times diameter times thickness. All right, so this under rivet consideration, the sharing of the rivet hole at the edge of the rivet plate. So you simply make use of this relationship 3 times diameter times thickness to actually calculate that. Now the final failure consideration is the failure of the rivet hole due to splitting of the edge of the plate and the rivet hole. The failure of the rivet hole due to splitting of the edge of the plate and the rivet hole itself. So you have something like this. This is the edge of the rivet plate, and you have a splitting, okay, and you have the hole there, something like this. All right, so this is a typical example: the failure of the rivet due to the splitting of the rivet hole at and the edge of the plate. All right, so this does not actually have a mathematical relationship, but it is still under consideration. Now amongst these four which has mathematical relationship, three are of utmost importance: the tearing strength consideration, the shearing strength consideration, and the bearing or crushing strength consideration. So these are the three amongst all that we are going to be considering. We are also going to be neglecting this in analysis, but you can also do this. It's not bad. But in terms of calculating the efficiency of a rivet, you only consider the least amongst the first three listed here, and this is not included, but this is also an option when designing a rivet. All right, so this is also an option. Okay, now in calculating the efficiency of a rivet, you have to know the strength of the rivet. The strength of the rivet lies in the least between the tearing strength, the shearing strength, and the bearing or crushing strength. The strength of every rivet lies in the least possible value between the tearing strength, the shearing strength, and the bearing or crushing strength. So whenever you're designing a rivet joint and you are done calculating the values of the tearing, shearing, and bearing strength, the least possible one, the one that has a smaller amount of number, becomes the strength of the rivet, because it is from that measure that you can tell where failure starts on the rivet. So when you pick out the least possible number, you can now design and strengthen that possible number against failure. Okay, so the strength of a rivet is simply the least of the first three mentioned over there. To calculate the efficiency of a rivet, okay, to calculate the efficiency of a rivet, it is simply equal to the strength of the rivet, which is the least of the tearing strength, shearing strength, and bearing or crushing strength, all over the strength of the unriveted plate. All right, so it is simply the least of the tearing, shearing, or bearing strength divided by the strength of the unriveted plate. We are the strength of the unriveted plate, okay, strength, we are the strength of the unriveted plate is given as the pitch times the thickness times the tearing stress. Okay, sigma T stands for the tearing stress. So this simply implies that the efficiency of every rivet is simply the least of Fx or Ft, Fs, and Fb slash C all over the pitch times the thickness times the tearing stress. All right, so multiply by 100%. All right, so this is the equation to calculate the efficiency of every rivet joint. Okay, that's the equation to calculate the efficiency of a rivet joint. Now, in most cases, a question could be given to you without the pitch, and that means to find the value of the tearing strength will be quite difficult because in the tearing strength we have pitch minus diameter. So if pitch is not given to you, all you need to do is, after calculating the value of the tearing strength without the pitch, which means you need to find the value of the pitch, and without the pitch you cannot be able to calculate the efficiency of the rivet. So all you need to do is equate the tearing strength to either the bearing strength or to the shearing strength. You can equate it to any of the equations and obtain a value for the pitch. Okay, it's highly permissible. At the end of the day, you can always achieve the strength of the rivet, which is the least number between the three. It can always come out. Okay, maybe when we take a real example, I will explain all of that. But this is how you calculate your efficiency, and this is how you design your rivet. So in the next video, we are going to pick an example, like a real example, to explain everything we've learned. The video is